Welcome to video number 4 of my Intro to Mathematica for Linear Algebra at Mississippi State University. Here in video number 4, we are going to talk a little bit about vectors, how you define them in Mathematica, and what are some of the few different things that we will need to know how to do with vectors. And then we'll see in video number 5 how we can start combining all this stuff we've been covering in the first 4 videos into a few application problems that show up within a linear algebra course. So just like normal, let me share Mathematica on my screen with you all. And so as I've said on every video, this is our notebook file that we're going to work within. And like I said, we're going to do some focus on some vectors today in this 4th video. So let me begin by showing you all how you will define a vector in Mathematica. We've been defining matrices a good bit the first 3 videos, but vectors are just a little bit different. So let's do 2 vectors, and we're going to do vectors that have 5 elements in them. That's the ones I made up this morning. So I'm going to begin by calling the first vector u. And you might remember from video number 1 that when I define vectors, or I said when I start defining vectors, I would use lowercase letters, and I usually use capital letters for matrices. So let's start with lowercase u, and we're going to do equals. And so when you do a vector within Mathematica, we are going to open a brace like we're used to, but at this time, instead of opening up a brace for every row, Mathematica understands that if you open one brace, type all of your elements with commas between them, and then close your brace, it understands that as a vector. So let me show you. I'm going to do -7, 5, -1, 4, and 8. And then I'm going to input this. And what you will notice is that if you do matrix form of u, it understands that to be a column vector, which is how we denote vectors in linear algebra. So you don't have to actually input an extra brace around each number to indicate the row. It's understood if you just do a list of numbers within braces. Now, similarly, I'm going to also do a vector v, just so I have a second one to work with. Let's do 13, -2, -1, 0, and 5. And just to show you the exact same thing, if I do matrix form of V, you see it understands that it is a column vector that I would like to work with. Now that we know how to define vectors in Mathematica, here are a few things that I would recommend you know how to do. So the first one is kind of like with matrices. You need to be able to add and subtract vectors from each other. So whether you do u plus v, or whether you do v minus u, whatever it may be, you can do the same types of operations like you do with matrices. And similar to matrices, if you add the matrix form around the addition or even around the subtraction of vectors, it will put it in the column vector form that we are traditionally seeing when we work with vectors. So, like I said, no different from how you did matrices, only just how you're defining the vector a little bit different. Now, with vectors, there is a couple of things that are unique to vectors that do not work with matrices. And so the first one is actually magnitude. So magnitude is defined as the length of a vector. And so if you want to find magnitude within Mathematica, there is no built-in code called magnitude. Instead, in Mathematica, we call this the norm of a vector. So if I want to define, let's say, the norm of u, which for us would mean the magnitude of u, we would input that and you will get your value. If you did the norm of v, you would get your value. And one thing you will note here is that Mathematica is going to try to find an exact answer for your magnitude. So whether that be the square root of 155 for the magnitude of u, or if you want to do the square root of 199 for magnitude v. So one thing you might notice is that one of the problems may ask you to do an approximation of that. Instead of an exact answer, what's the decimal going to give you? Let me show you how to do that. So let's say on magnitude u, I want the decimal instead. It's one simple extra line of code to add. Around the norm, where we're used to doing matrix form, instead, we're going to use a capital N and then group what we want to approximate. So this capital N in Mathematica is known as the numeric approximation built-in code. And essentially that just means Mathematica is going to find a decimal for that. So if we wanted to find the decimal of root 155, that would be 12.4499. Or if you wanted to find the decimal approximation of the magnitude of V, that would be 14.1067. So if we want exact answers, you can just leave the norm of U or whatever it may be. But if you need the decimal to do whatever it is you may need to do, make sure you add that capital N around it, and it will do a decimal approximation. And so that's magnitude. The second thing that you need to know how to do, especially for some of the chapter 6 applications, is dot product. And so you've actually already seen this code in Mathematica in the first video, but we're going to do it again. So dot product is found by just using the period between the two vectors you plan on doing the dot product of. So if I wanted to do the dot product of the U and V vector that I just defined, I would just do U period V, and Mathematica will compute the dot product of those. As we've talked about during lecture, the order you do the dot product doesn't matter. You should get the same number. But as you've also seen, especially if we've made it to chapter 6 already, you can dot a vector with itself, whether that be for us doing U dot U or V dot V. We can find the dot product of a vector times itself, which shows up a lot in the applications of chapter 6. And so dot product is definitely something you need to know how to do. Now, some of y'all who may also be in my calculus class and have watched the videos in that series, or if you've done calculus already before you took this class, you might remember that there's a cross product idea. We actually don't use cross product in this class. It's not necessary. The idea of a cross product means we need another vector that's orthogonal to the two vectors we're working with. And as far as an intro to linear algebra course, nothing we do involves cross product. So if you want to look up how that works, you can do that, but I'm not going to worry about teaching it during my intro videos here. Now that we know how to do magnitude and how to do dot product, keep in mind that, like in the last video, you may be asked to combine some of these things together. And so while I told y'all in the first video, we don't use the math palette very often in this class for the problems, here's where you might see me to use it for the first time. So remember, under the palettes tab, if you go down to other, and I like to use the basic math input, what you will notice is that there are going to be some problems on your project where you might have to combine a couple of things. And so while I'm not going to use any of the complicated stuff on here, one that might be useful is this fraction notation. Because one thing you might see us do, and I'm going to kind of make one up here for us, is I may ask you to do in the numerator, I want you to do the dot product of U and V. But in the denominator, I want you to find the magnitude of U. And so if you wanted to do both of those at the exact same time, we could do it this way, where Mathematica will find the dot product, it will find the magnitude, and it will do the division. As you can see, it spits out an answer. If you need to change something, let's say you wanted to do the U dot U, but divide it by the norm of V, you can do any combination that you need to, and Mathematica will compute that particular value. So let's do another one. Let's say if we do a fraction, let's go back to U dot V. Let's divide that by the norm of V. And let's say I want to then multiply this by another vector U. So then I will multiply it by another vector U on the end, which if I do that, since I'm adding that extra vector in, you might notice that it puts it in a vector notation. Remember, just like matrices, if you want to see a vector in its better syntax, you can add matrix form around it, and it will put it in a matrix form for you. The key here to notice is that all this is saying is that you can do multiple different things at once. Just make sure that you are putting them in the order that either the formula dictates from lecture or in the order that you want Mathematica to do it. And so that is where I'm going to wrap up this very short video 4, and you're about to see why. This video covered the basics of how do you define vectors in Mathematica, how do you find magnitude, how do you find dot product, and then how do you do some of the basic combinations of those. The reason I'm making this video a little bit shorter is because the fifth video will probably be the longest of the series. In that video, I'm going to combine everything we've learned in the first 4 videos, and I'm going to show you all 5 different applications of linear algebra using the codes that we have talked about. So this will kind of be the ending point of the video series after video 5. And after that video, you will have the tools in order to begin working on your project or hopefully to finish your project here. But I will see y'all for video number 5 to wrap up the video series for Intro to Linear Algebra.